Hi and welcome. Today in this video, we would be discussing about Chapter 2 Polynomials, which is a chapter over there in NCERT Textbook Grade 9. In this chapter, we would be primarily focusing about what are polynomials, what are algebraic expressions, operations in polynomials, and some of the identities over there in polynomials and algebraic expression. So let's move to the contents of it. Let's see what are the topics that we would be discussing in this chapter, and then we would be discussing each of them individually. In this chapter, we would be focusing upon algebraic expression, polynomials, remainder theorem, factor theorem, and algebraic identities. However, in this video, we would be focusing only on the first two parts, algebraic expression and polynomials. Let's move towards the first part, algebraic expressions. So yes, let's start with the topic of algebraic expression. Before moving to algebraic expression, when you hear the word algebraic expression, I'm sure that the first thing that might be coming to your mind would be x, y, and z, because those are the terms that we generally use in an algebraic expression, right? So let's first get in touch with the terms that we would be using in an algebraic expression, and then let's move towards the other part. Now, in an algebraic expression, we would be writing it as it would be a combination of constants, variables, and operands. Let's take them individually and see what constants are, what variables are, and what operands are. Now, when you talk about constants, constants are values which are fixed. For example, like 2. 2 will be always 2. 3. 3 will be always 3. 1001. 1001 will be always 1001. There is no change in that value, right? Its value is always fixed. You cannot change it. But at the same time, variables are the people or are the numbers whose values can change. For example, depending upon the situation, the values can change. For example, I'm taking a square over here, all right, and I'm saying the perimeter of the square is depending upon the length of the square, right? Length of the side of each square. So if the length is x, then the perimeter would be 4x, right? Then the perimeter of the square would be 4x. So perimeter depends upon what? The length of the square. So the length of the square can literally change depending upon the time and depending upon the kind of values that it can take. It literally can change, right? So variables are those people whose values are not fixed. They can change depending upon the situation. Now, I told you what constants are, I told you what variables are. Now let's focus upon what are operands. Now, operands are the operations that we do in mathematics, like plus or subtraction, adding or multiplying or division. All these things are known as operations. And the people those who are doing that operations are known as operands. For example, plus sign, 2x plus 2, the first example, which is given over here. Let's take it. So 2x plus 2 has two constants. One is this 2 and the other one is this 2. And there is a variable over here, which is x, right? And there is operand over here, which is plus, right? In fact, there are two operands, like 2x can be written as 2 into x, right? And that plus 2. So there is an operand over here into, and there is an operand over here plus. So there are different kind of operands over here. As you can see, there is two operands over here, and there are two constants, and there is one variable, that is x. Now at the same time, if you think about it in a different way, I can multiply here with x to the power 0, because we know that any number to raised to the power 0 will be always giving you 1. So 2 into x to the power 0 means ultimately it means 2 into 1, which is 2, because x to the power 0 means 1. So 2 into x to the power 0 can be written as 2 itself, or 2 can be written as 2 into x to the power 0. So 2x plus 2 can be written in different methods, 2x plus 2x to the power 0. This is also an algebraic expression. I hope you have understood how can we write what an algebraic expression is and what operands are, what variables are, what constants are. When you start talking about algebraic expression, remember an algebraic expression is a combination of constants, variables, and operands. These three should be present in an algebraic expression. Now, even number 2 is considered as an algebraic expression because 2 can be written as 2 into x to the power 0. Right? So there is variable, there is this constant, and there is an operand which is into between x, 2 and x. So we can consider like that, but generally we will be considering it as a constant because there is only one value for 2, which is 2. But if you represent it like in this format, then yes, you can consider it as an algebraic expression. Coming back to the topic, we have already learned some of the identities like these. These are known as identities, algebraic identities. X plus y the whole square is equal to x square plus 2xy plus y square. Similarly, x minus y the whole square is equal to x square minus 2xy plus y square. I'm sure that this is not y2, it is y square, and this is x square. Similarly, over here also it is x square and this is y square. So x plus y the whole square is equal to x square plus 2xy plus y square. X minus y the whole square is equal to x square minus 2xy plus y square. X square minus y square is equal to x plus y into x minus y. So I hope you have understood what these identities are. In fact, you have learned it already over there in 8th standard. I'm just trying to make you recall all the things that you have learned over there because it is necessary for us to move further in this chapter. So algebraic expressions are combination of constants, variables, and operands. These three must be present in an algebraic expression. Why am I explaining this algebraic expression is because I want you to understand the basic concept of polynomial by understanding what an algebraic expression is. You will be further going towards the polynomial part in a while. Let's move towards the main topic in this segment, that is about polynomials in one variable. Now, why I have taken the algebraic expression just before this topic is because to understand polynomials, you have to get the basics of algebraic expression. Because even in polynomials, we use constants and variables. So you might be thinking, what is the difference between a polynomial and an algebraic expression? Well, there is a difference between polynomial and algebraic expression. Can you just try to think what it is all about? I'll give you certain examples and I'll be trying to ask you, I'll be just giving you some examples and try to find why they are considered as polynomials and others are not considered as polynomials. So 2x to the power 2 plus 3 is considered as a polynomial. At the same time, 2x to the power 1 by 2 plus 3 is not considered as a polynomial. Again, another example that I can give is about x to the power 100 plus 3x is considered as a polynomial, but root x plus 4x is not considered as a polynomial. The reason is very simple. If you look over there in the first two examples that I've given, first and third example that I've given, you can see that the power that they raised to is a whole number. So if the power of an algebraic expression, these all are algebraic expression, all of them, all four of them are algebraic expression. But if you look over here, you can see that the power over here in this particular algebraic expression, the first and third examples, it is a whole number. At the same time, over here, the power which is given over here, their powers are not whole numbers, which ultimately means they are not a polynomial but an algebraic expression. They will be just an algebraic expression but not a polynomial. I hope you understood what it is about. I hope you understood the theory behind it, what a polynomial is, right? We have already discussed about what constants are and what variables are. So if in case in terms of a polynomial, if we start talking about a polynomial, in in a polynomial, it should be an algebraic expression first of all, and that algebraic expression's variable, all types of variables should be raised to a whole number as a power. It shouldn't be fraction, it shouldn't be decimal, it shouldn't be a kind of, a kind of complex number or something. It should be whole number. It should be literally whole number, nothing less or nothing more. So I hope you understood about it. What a polynomial is. The algebraic expression who has whole number as exponents of the variables is known as a polynomial. If what is a polynomial? It is an algebraic expression and it should be having whole number as the exponents of the variables. So if you look over here, I have given some examples for you to do, like this one. So this one are having what? There are two variables over here, one here and two variable. Now, if it is having only one variable, if you're asking polynomial in one variable, there should be only one variable, right? There are two variables here. There is x and y. Is it a polynomial? Yes, it is a polynomial. Is it a polynomial in one variable? No, it is not a polynomial in one variable. It is a polynomial because its variables are raised to the power of a whole number. But there are two variables, so it is not a polynomial in one variable. There are two variables, that is x and y. So in the next part, there is only one variable x, but the variable is raised to power what? A known whole number. It's a fraction. It's a rational number. So we don't want that over there. So it is not a polynomial. It is not a polynomial at all, but it is an algebraic expression. At the same time, you can see here in this question, they are having only one variable and it is raised to whole numbers. Both of the sides, it is 3y to the power 1, which means both of them are raised to a whole number. So it is a polynomial in one variable and it is an algebraic expression. So I hope you understood what polynomial in one variable is. Let's move to the next part now. Now let's move on towards the terminologies used in the polynomial. Uh, there are different kind of terminologies that you would be coming across when you start the topic of polynomial. We would be explaining it using an example, that is 3y square plus 5y minus 7. The first terminology that we are going to learn is about terms. Now you can see that there are different numbers over here like 3y square and 5y and minus 7. All these individuals like 3y square, 5y and 7 or minus 7 are terms of this polynomial. The reason why we call them terms are because they got separated with an operand plus and minus. If they are getting separated with plus or minus, we call them as terms. Not by multiplication or division, but plus and minus. So terms are the parts in a polynomial which get separated by plus and minus. So 3y square is a term, 5y is another term, 7 is another term. Let's move towards the next part, that is coefficient of y square. Coefficient means you can see that over here in this example, uh, you can see there is y square, there is y, and here there is y to the power 0. So even though y is the variable over here, the power in which y is raised is different in different terms, right? So over here, when we start talking about coefficient, if I'm saying what is the coefficient of y square, it means that the constant near to y square, who is he? That is 3. So coefficient of y square is 3. So coefficient of a term means a particular term or a variable means that near to that variable, who is the constant, that is known as the coefficient. I hope you understood about it. So y square's coefficient is 3 and y's coefficient is 5 and y to the power 0's coefficient is minus 7. Not 7 but minus 7. It's not plus 7, right? It is minus 7. So coefficient of y square is 3, coefficient of y is 5 and coefficient of y to the power 0 is minus 7. It's actually minus 7. I'm just literally made it a mistake over here in terms of the printing. So I hope you understood what coefficients are. Let's move towards the next part, constant polynomials. Now, when you look over here, you can see that minus 7 is always, it would be always remaining as minus 7. Even if the y value is changing, even if it doesn't depends upon the value of y, right? Its value is always fixed. Minus 7 will be remaining as always minus 7. Similarly, if it is 2, it will be remaining always as 2 because its value is fixed. But still it is a polynomial because it contains 2 means what? 2 into x to the power 0, right? So which means 2 into 1. Any number raised to the power 0 means what? It means 1. So 2 can be written as 2 into x to the power 0, which means 2 into 1, which is 2. I hope you understood what constant polynomials are. The polynomials whose values will not change even if the variable is changing, they are known as constant polynomial because ultimately x to the power 0 will become what? Automatically it will get converted into 1. Any number raised to the power 0 will become 1. Okay, I hope you understood what constant polynomials are. Let's move towards the next part, that is degree of a polynomial. Now when we start talking about the degree is uh, the maximum power or the largest power the polynomial's variable is raised into. Like over here, the largest power the variable raised into in this polynomial is 2, right? Here it is 1 and there is 0, but here 2 is the largest power. which means the variable is raised to the largest power 2. So the degree of this polynomial will be 2. So if I'm writing x cube plus 3x square or x cube plus 3x, the largest power over here is 3. So the degree of this polynomial will be 3. I hope you understood about it. The next thing that we are going to learn is about naming of a polynomial. Now, when we start naming the polynomial, it depends upon the number of the degree of the polynomial. If the degree of the polynomial is 1, for example, if it is x plus 1, what is the degree of this polynomial? That is 1, right? Because x is raised to the power 1. So in that case, we call it as a linear polynomial. Linear polynomial. All right. If the degree of the polynomial is 2, x square plus 2, if I'm writing, in that case, the degree of the polynomial is 2 because the maximum or the largest power that this polynomial's variable is raised to is 2. So if the degree of the polynomial is 2, we call it as quadratic polynomial. All right. Similarly, if the degree of the polynomial is 3, x cube plus 4 I'm writing, then the degree over here is 3, which means it is a cubic polynomial. We call them as cubic polynomial. So linear polynomials are the polynomial whose degree is 1. Quadratic polynomials are polynomial whose degree is 2. And cubic polynomials are polynomials whose degree is 3. Now, towards the next part, monomial, binomial, and trinomial, very easy they are. Let's start with giving some examples of it. Monomials are polynomials who are having only one terms. For example, x, if I'm simply writing x, it is having only one term, or 2x, or 3x. They're having only one term over here, right? 3x, 2x, 5x to the power 100, right? They're having only one term. So each of them are having only one term. So if they're having only one term, we call them as monomial. At the same time, if I'm having 2x plus 2 or 3x plus 3 or 3x plus 4 or 5x to the power 100 plus 2x to the power 2 or 2x to the power 3, there are two terms in each of these polynomials, right? So if there are two terms, we call them as binomial. In the same way, if there are three terms like 2x square plus 2 plus 3x, this is there are three terms here, 1, 2, 3. Another example that I can give is 5x to the power 100, 3x to the power 50 plus 2. This is what, there are three terms here also. If there are three terms, we call them as trinomial. So monomial are polynomials which are having one term, binomials are polynomials which are having two terms, and trinomials are polynomials which are having three terms. I hope you understood about it. Let's move towards the next part, which is basically some of the exercise in your NCERT textbook. Let's start with some of the NCERT questions, and let's do it very quickly, and let's wind up this session fast. So first question is to find the degree of this polynomials. Now degree means the largest power the variable in that polynomial is raised to. Now in this first part, x to the power 5 minus x to the power 4 plus 3, the largest power is 5. So the degree is 5. Similarly over here, in this polynomial, there is degree 2, there is degree 3, and there is degree 8. Even there is degree 0, which is which is something that we are not considering. But here the largest one is 8. So the degree of this polynomial is 8. Similarly over here, you can see that in this polynomial, 2x to the power 0 it is. Even though it is written as 2, it means 2x to the power 0. The degree over here is 0. Now, next one is we have to find which of these are polynomials. So here we are having questions like 4x to the power 2 minus 3x plus 7. So if the power is raised to a whole number, if the variable's power is raised to a whole number, then we can call it as a polynomial. So over here it is x to the power 2 and x to the power 1 and x to the power 0 over here, which means it is a polynomial. And here in the second question, y to the power 2 and 2 to the power 2 into x to the power 0, sorry, y to the power 0, which means this is also polynomial as the variables over here is also raised to a whole number. Now over here in the third question, 3 root t. Root t means t to the power 1 by 2. Root t means t to the power 1 by 2. So 3 root t plus t root 2, it is actually quite confusing, and I'm sure that Since it is a rational number, since it is a rational number, we won't be considering it as a polynomial, because for a polynomial, the variable should be raised to the power of a whole number. Next one, we have to find the coefficients of x square. Now over here, you can see the coefficients of x square in this question is 2 plus x square plus x. So the constant which is near to the x square, that is over here, it is 1. So the coefficient of x square in this polynomial is 1. Let's move to the second question. 2 minus x square plus x cube. So here the coefficient of x square is minus 1. So means the constant which is near to x square is minus 1. So the coefficient of x square is minus 1. Similarly over here, the constant which is near to x square is pi by 2. Always remember, pi is a constant as it is having a fixed value which is 22 by 7. A constant's value will be always fixed. Pi cannot change its value, right? So pi by 2 they have given here. So pi by 2 is the constant which is near to x square. So the coefficient of x square is pi by 2. Next one, give one example each of a binomial of degree 35. So a binomial of degree 35 would be x to the power 35 plus 3. Or you can form anything as you like. It's totally your wish. Y to the power 35 plus 2, 2x, 2y to the power 2. You can write literally anything. And next one, a monomial of degree 100. A monomial of degree 100 means I can write x to the power 100 or y to the power 100 or z to the power 100. It's according to your wish. Write the degree of each of the following polynomials. Again, the same thing is getting repeated. We just have to find, the degree. Degree means the largest power the variable is raised into in each of this polynomial. Here there is 3 and there is 2 and there is 1, which means the degree over here is 3, because 3 is the largest power the variable is raised to in this polynomial. Second one, 4 minus y square. Obviously, it is 2, because 2 is the largest degree the polynomial is raised to. Last question, classify the following as linear, quadratic, and cubic polynomials. Linear having only one term. Linear is having uh, only degree as 1, and quadratic is having degree as 2, and cubic is having its degree as 3. So over here, you can see that x square plus x having degree 2, which means it is a quadratic polynomial. Next one, x minus x cube, it is having its degree as 3, which means it is a cubic. And here, this one, again, y square is coming here, which means this is the largest degree it is raised to. So this is what a quadratic polynomial, and 1 plus x is again a linear polynomial because its degree is 1. So if it is having degree 1, it means that it is a linear polynomial. Thank you. I hope you have understood about all the NCERT problems that we have discussed about. You can literally comment anything and I'll be responding to it. If you have any doubts or something, I'll be responding to it very quickly. If you have liked this content, please do subscribe, share, and comment. Whatever you feel about it. Your feedbacks are most valuable for us, and thank you for listening to me. And this is Mohammed Sabit signing off with you, Tutors. Thank you.